in math, but whichever side looks worse, you have to work with that. Another strategy is to turn everything into sine or cosine. So if you recall, like secant is 1 over cosine of y, and cosine is just cosine of y. Another point here is that these are not equations. I need to actually say that these are not equations. So you cannot move things around. You only work on one side. So you can't add stuff, you can't divide, you can't multiply. You need to prove that this thing on the left becomes 1. Now, depending on your instructor, sometimes like you could actually just go right to the answer after. You could actually say, oh, well, this is 1. Some really want you to write out every step when you're doing this. So think about what your instructor does in class. Think about how particular they are about some of that stuff. And when you're doing this. So here's another problem to look at. Which side is more complicated, Niko?
The left.
The left side. So, all right, we're just going to go sine squared t, and then tangent is sine squared t over cosine squared t. And again, we're not working on the right-hand side. Like that's your target. You know where you're trying to go, but you can't do anything with it. So here, if you don't remember, when you're dividing, you multiply by the reciprocal. And you do have to show all this stuff. You can't just, like for me, I could just say, oh yeah, it's cosine squared t, but the emphasis here is actually on writing out all the steps, showing that those cancel and you get cosine squared t when you're done. All right. So let's go look for some harder ones here that are more interesting. Let's go to so let me just see here. So Jamie sent over some of them. Take a look at that. Yeah, we'll get to that. Yeah, I mean, you are going to be asked to do this on a test or quiz. Let me pull up one, I guess, that I think is better for us to start with. If that's okay, because I'm not seeing this in your homeworks assignment yet.
Okay.
So this one, this is an equal sign here. So to me, the more complicated side is the left side. So that's what we're going to work with. And this is kind of a better example of what I was talking about. You want to write everything in terms of sine and cosine. That's one of your approaches. So tangent is sine x over cosine x. Sine x is obviously sine x. Okay. Now, if this were numbers, what would you do with the fractions? Hopefully you would say, okay, I would combine them, right? So it's 1 minus sine squared x, because sine times sine is sine squared, over cosine x. Okay. So do you guys remember the Pythagorean identities?
Yeah.
Do you have that reference sheet? So we know that sine squared x plus cosine squared x equals 1. So in this case, cosine squared x equals 1 minus sine squared x. So if you have that trig reference sheet I've sent you before, that cheat sheet, you're going to use a lot of that in this part of the course. So this numerator, sorry, I went past it. This numerator is cosine squared x over cosine x. And then obviously that one cancels with one of those, so you leave just with cosine x. But that's not the answer. This one wants 1 over secant x. Like, well, how do you do that? Well, that you need to know your reciprocal identities. This is 1 over secant x. And if I come off to the right here, 1 over secant x is 1 over cosine x, which is cosine x. So you got to be careful that you actually stop with the thing that you're trying to get to. So the ones you sent me, Niko, like I wouldn't think any of these are difficult enough to get onto an exam. Maybe after like 22, 24, those are kind of more what I would expect you to see on an exam. So we can do one of those if that's okay.
Yeah.
All right, so let's do So it's interesting. Like 24 has so much going on in it that it's there's a lot there. Okay. Jamie, then I'll jump over to one of your problems here after this.
Okay.
So this looks really complicated on the left. So that's obviously the choice, but maybe you don't know what to do. Again, that strategy of using sine and cosine is a pretty good one. You almost always use that when you don't have any squares or any like 1 pluses or 1 minuses, like in this case. So this is, and you don't have to keep writing this, although you probably should. You can for example, you can write 1 over cosine because that's secant over sine over cosine. I'm sure your instructor wants you to put all that in, but it's a lot of writing. So this becomes 1 over cosine times cosine over sine, like that. Is that okay? Just flip the bottom.
Yeah.
Cosines cancel. Great. So you get 1 over sine of pi over 2 minus x. I'm going to throw in that that cheat sheet again, unless you guys already have it up. I got to pull it up myself because I want to reference the cofunctions here. So let me put this in the chat so you know what I'm talking about. So there's that sheet. I'm going to snip in the cofunctions for these. There's 6 of them. Grab those here. Okay, so sine pi over 2 minus x, or in our cofunction there minus theta, it's this top one. So this part on the bottom just becomes cosine x, and 1 over cosine x is secant x. So there's a lot to remember when you're doing these problems. There's a lot of like little forks that you have to be able to work through it, to navigate when you do that. Okay, Jamie, I'm gonna grab, is it question 6 that you want us to look at?
Yeah.
Okay.
On there, it's just like 6 and 7.
Okay. So this one actually tells you what to use. I mean, your test probably won't be that nice. It actually says here, use cofunction identities to evaluate the expression. Okay. So well, let me grab them again here. Okay. So instead of pi over 2, you can use 90. So for example, this first one could be sine squared of 51. Like we could use that. The second one could be sine squared of 11. Is it okay? Is it clear how I'm getting that?
Yeah.
Okay. Now off to the side here, sine squared x plus cosine squared x, what does this equal? Equals 1. And it doesn't matter what x is.
Oh, okay.
Okay. So why is that important here? Well, what you really want is the angle inside to match. Okay, if you can. If we can get that to match, that's really, really good. So see how this one became sine squared 11? And this one is cosine squared 11.
Yeah.
These equal
They
1.
cancel, equal 1.
They equal 1.
Okay.
Now this last one here could be sine squared of 49. And so if I don't do this with the first one, if I bring the first one down here as cosine squared 49, and that last one is sine squared 49, then this also equals 1. So it's 1 plus 1, 2. Niko, yours are probably the same numbers, or I'm sorry, yours are different numbers, but it's the same, unless your signs change. But the red tells me that it's just the numbers. Yours probably equals 2 for the same thing. This is very commonly a placement exam question, kind of to test your knowledge of trigonometry at the various universities. So if you understand it, that's great. Let's look at the next one here, number 7. Use the trigonometric substitution to write the algebraic expression as a trigonometric function of theta, where theta is between 0 and pi over 2. So what they're telling you here is that I think they're saying, hey, this is a first quadrant problem. So here's your theta. And u equals a cosine theta. That's not very useful, but if you divide both sides by a, cosine theta equals u over a. Why is that helpful? Well, cosine is adjacent over hypotenuse. Okay. And then to solve for this side, let's call this side b. You would have u squared plus b squared equals a squared. And we're solving for b. So we're going to subtract u squared from both sides. Then we're going to take a square root. So b is the square root of a squared minus u squared. Okay, so that's up here. Square root of a squared minus u squared. Now I haven't answered this yet, but you have to be able to like actually determine this triangle. Niko, any issues with what I did there? Anything you would like me to clarify?
I think I got it.
Okay. So they're like, how can you just write this as a trigonometric function of theta and u? Okay, so you no. Theta. Algebraic expression as true. Okay, so our options are so I guess truth, I don't really know how to answer this because I'm not sure what it wants, but sine theta is the square root of a squared minus u squared over a. I don't think they want that. Tangent of theta is square root of a squared minus u squared over u. Kind of think they want that, but I'm not sure. As a trigonometric function of theta. Do you, I don't know, how many attempts do you have here?
I got 5. Quick question.
Yes.
Is it, I don't know if this is allowed in this kind of problem. Are you allowed to just plug in a cosine of theta for the u? Or is that not allowed in there?
Like for the u? Oh, you mean over here?
Yeah.
Yeah, you can do that.
Okay. How would the square work out? Would it square the a in there?
Oh yeah. Oh, I think, well,
Love the
actually,
cosine?
I actually think that, I think you've got the right answer there. So it's a squared minus a cosine theta squared.
Mhm.
And then you square a cosine
Got
squared
it.
theta. Okay.
Okay.
So now you can factor out an a squared out of both.
Okay.
This is now I'm seeing this is the
Oh,
correct
and
answer,
that's
I
one of
believe.
the identities.
This is one of the identities. This is sine squared
Got it.
theta. And then you take the square root of a squared times the square root of sine squared theta.
Mhm.
And you get a times sine
Sine squared.
theta.
Okay.
Just sine.
Yep, that was right.
So did this work? Was this the correct answer?
Yeah, it worked out.
Okay. All right. Niko, back to you here. Do you want me to do some more of those trig identity problems, or
Yeah, can
I'm
we do
sorry.
that other one? I don't know, I think it was 22. What other
Yes.
one was the hard one?
Yes, let me get to it. We did one of them, but there's so many here that we can do. Oh, 22, sure. Yeah, let's do 22. This one's got a lot here. Okay. Jamie, which is the more complicated side? Which one looks worse to you?
That's got to be the left side for sure.
Yeah,
right?
I would agree. Sometimes it's a toss up, but I don't think so in this one. Sometimes there really isn't a clear like path to the solution. So you got to look at it and be like, all right, well, what's there? What's not there? Like what I see is that you could, like, if I didn't know anything else here, you can actually factor out secant x tangent x from both. Like I said, these are in both. Okay, that's maybe helpful. I'm also drawn to the fact that there's secant to the fourth out in both of those. Like I can take a fourth out. The other thing though is that you've got to stick to what you're going to be able to substitute in for. And this is one of those Pythagorean identities. I'm just going to grab it right here. You've got to know all three of these really well. And like the one that it looks like we're going to use is probably this middle one. Because you can kind of see that like there's a secant squared minus 1 here, kind of. Okay, so let me do the following here. And this is just a guess. I'm going to factor out the secant x tangent x from both of these. So that gives you secant 6x minus secant 4x. Is that okay? Is that clear? So now I mentioned this before, like there's 4 secants in each of these, so we can actually factor out 4 of them. So it becomes secant squared x minus 1. Hey, that's good. That's over here. And then you got the secant x tangent x over here. So this part becomes tangent squared x by the identity. Niko, is that okay? Or do you need more clear? You need me to clarify that?
I think I got it. Okay, yeah.
Like it's okay to write, write what is it? Secant squared theta minus 1. You also have to be really careful that you don't mistake it for being tangent squared minus 1. So your instructor might throw a little wrinkle in like that where you actually don't use the identity because it's not right, or you have to manipulate it a little bit. But our next line here is secant x tangent x secant to the 4th x tangent squared x. You're multiplying all these, so these multiply together and then these multiply together. And that gives you your final answer, secant to the 5th x tangent cubed x. And that was our target. That's what we wanted.
Okay, I got it now.
Jamie, do you have any of these from homework that you've either done or want to look at? These are worth doing. Like they're all a little different. And if you haven't seen it before, and you probably won't, you just have to like have enough confidence to know, like, okay, let me try this and see if this works.
I'll take a look.
Okay, let me look and find a couple more that I know are common here on the exams. Don't like any of those. All right, here's another one that I think might be worth looking at. All right, verify the identity. Verify the identity. So the left side's more complicated, so we're gonna work on that. You probably notice right away that they're different denominators, so you can't just combine them. one strategy again is to turn everything into sine and cosine. So let's try that. So that's 1 over sine x plus cosine x, 1 over cosine x equals, well, we're not doing that. So then you just flip it. You flip the fractions here. So you get sine squared x over 1 plus cosine squared x over 1. And then that is your identity. Or that's one of your Pythagorean identities. That's one. You do have to show that that last line does equal whatever you're supposed to turn it into. So you have to write that at the end. And then some instructors, I guess they make you write some letters or some symbols. I mean, it's whatever you want on that for me. So you guys have some other problems you'd like to look at?
I
Yeah,
just
let
found
me look at my book.
I'm just gonna step away for 30 seconds. I got a trig book that we can pull some better problems from. I'll be right back.
okay.
All right, so got a couple here. Could be worth looking at. Some of these are things you haven't seen yet. Let me go back. Here's one we'll look at. Oh, these are all. Haven't done that yet. All right, so here's 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals 2 secant squared theta. Oh, you guys sent over some questions. We can look at those instead. Jamie, which one here is just one? Oh, it's just one.
Yeah.
Okay. Yeah, let's look at this question. Then Niko, I'll jump over to yours. So it says here even odd identities. Does that mean anything to you, Jamie? It's okay if it doesn't. I'm just asking to know where to start.
No.
Okay. The off to the side here, sine of minus x equals minus sine x because it's an odd function.
Oh,
Cosine is even, so the cosine of minus x is just cosine x. So that basically the negative goes away. This is worth remembering. Another even function, I think we talked about this, is x squared. Like if you put minus x and for x and x squared, it goes away. Okay, and another example of an odd function is like x cubed. We can look at that another time, but that's relevant here because the negative here ends up coming right there. So this becomes 1 minus sine of x.
and then do you just FOIL?
Yes.
Okay.
So when you FOIL, you get 1. This is a difference of squares. So the outer and the inner cancel. 1 minus sine squared x. Again, you're not allowed to work on left and right. So on the left here, this just becomes cosine squared x. And you can say, yeah, I've got it.
Got it.
It's correct.
Okay.
All right. Niko,
I sent you over some book work.
I see that. Yeah.
Yeah.
Is
It's more complicated.
Is there one you would like? Well, let me just do. I'll just do 60. I'll just do an odd or an
Yeah.
even in each group. What the hardest part of this will be when you get to the end of this chapter, when you take your test, is there are a lot of formulas to remember. And it wouldn't cram for them, but you know, you may have to. There's just a lot to remember when you do this. So this one, if you can see here, it's secant to the fourth x tangent squared x. The right side is tangent squared x plus tangent 4 secant squared x. Which side do you think we should work on, Niko?
The right side.
Right. Generally sums are more complicated than products. So let's take a look here. So you could do a lot of things. You could distribute. That's one option. You could write anything in terms of sine and cosine. Sometimes a mixture is good, like secant squared is 1 over cosine squared, but tangent is sine over cosine, so I'm not sure that's great.
Should we substitute out tangent squared?
I think that's a good strategy as well. So whenever you see squareds or powers bigger than that, you're probably going to use one of those Pythagorean identities. So in this case, if you factor the tangent squared x from both, you get 1 plus tangent squared x secant squared x. Okay. And then if you look at your, I'm going to go up and grab it from this previous problem. There it is, one of these identities. These are, you gotta have these down so that you can say, oh yeah, 1 plus tangent squared x is secant squared x. So it's a little bit of like pattern recognition. It's not really math. It's like, do you see the thing that you're supposed to use? So secant squared times secant squared, that gives you your secant to the fourth x. Obviously tangent squared gives you that. And that's it, because that's what we want. All right, let's look at 68. 68. This is Jamie, kind of like one of the ones that we did with the triangle earlier.
Mm-hmm. Oh yeah.
Okay, so what? It's probably not clear here, but the left side actually is the one you want to work on. We're going to do this. We're going to let theta equal sine inverse of x. Okay, and if you take the sine of both sides, sine of theta equals the sine of sine inverse of x. The sine of theta ends up just equaling x. So if I draw a nice first quadrant right triangle, sine theta is x, so you're like, all right, yeah, there's x. Well, what goes in the hypotenuse position? Well, you can write it over 1. Yes, you got to remember that. How do you find this one over here? So that's the a squared b squared equals c squared. If you do enough of these, you'll get pretty fast. You'll say, oh yeah, it's 1 minus x squared square root. So it's the square root of 1 minus x squared. Now, why did we do all that? Because when we made the substitution here, what we really said is we really want cosine of theta, because theta is sine inverse of x. So cosine of theta is adjacent over hypotenuse. It's the square root of 1 minus x squared over 1.
I cut out for a little bit, like something on my internet. Can you explain the first part again?
So you always let theta equal whatever is inside here.
Okay.
Okay. We're going to do a more complicated one, but and then when you do that, you have to draw this triangle.
Okay. Okay.
So Jamie, you heard me. Do you remember how I just said, well, it's in the first quadrant here, but we find theta because we really want cosine theta. And we had to find this missing side using Pythagorean theorem.
Yep.
Okay, so we're going to look at another problem here. So we'll look at 70. And I'm not even going to copy in the right hand side, because we just need the left hand side for now. So you let theta equal the inside part. And then and then you solve for the inside part. So you take the cosine of theta, and that cancels this out. So it's x plus 1 over 2.
So it's x plus 1 and then 2.
Yeah. So Niko, you just label
Got
the
it.
triangle, based on whatever this is. This is, adjacent over
Oh,
hypotenuse.
okay, okay.
And then you got to find the third side here. So go ahead and find that other leg for me, and then I'll work it out here shortly if we need to. So the missing side here is this, the hypotenuse squared 4 minus x plus 1 in parentheses squared, square rooted. Is that what you guys got?
Yeah.
Okay, so like all this work we just did is no longer needed, because what we really want is tangent of theta, because this whole thing is theta. That's what the substitution was. So tangent of theta is 4 minus x plus 1 squared over x plus 1. So you're just writing, whatever it is. If it was cosecant of theta or cotangent or secant or sine, whatever it is, you just use the sides as needed.
Okay.
All right, Niko, is there something else you would like us? I'm sorry, Jamie, is there something else you'd like us to look at tonight? Any other web assigns that maybe?
Not really. I'm all caught up for the most part. I'm trying to look for any last things.
Yeah, Niko.
I'll look. Let's see. I don't think there's anything else in the book. I think I'm good.
All right, let me pull up another problem here on my side. This won't help you guys because this is me playing the role of the teacher and saying, hey, this is a really good question. I like this question because there really isn't a clear which side is more complicated when you verify the identity. But there is maybe one thing you could use to justify it. There is no, like, you can actually work on either side here, but I tend to think the left side is more complicated because I think cotangents are more complicated than tangents.
Mhm.
Do you agree, disagree? What do you think?
Probably agree.
Yeah.
Okay. So because we need like a reason, like if you got to figure out path A, path B, you got to, okay, well, that's our reason. So because I don't know any better, I'm going to write it as 1 over tangent of alpha plus 1 over 1 over tangent of alpha minus 1. Now, whenever you have what are called complex fractions within fractions, you generally want to make a common denominator. So your common denominator is, and working vertically, you really are supposed, that's another thing I didn't mention, you're really supposed to work vertically. I know they don't give you a lot of room sometimes to work these out, but you're not really supposed to like go horizontal and then vertical, but maybe ask your instructor if that's a big deal. On the top here, we'll multiply the top and bottom by tangent of alpha. Same thing here. Okay, so it's 1 plus tangent of alpha over tangent of alpha in the numerator, all over 1 minus tangent of alpha over tangent of alpha. So whenever you have the same bottoms, they cancel. and you write 1 plus tangent of alpha over 1 minus tangent of alpha. I believe that's what it wanted.
Yeah.
All right, so let me have you guys try one here on your own, if you don't mind. 1 over 1 minus sine theta plus 1 over 1 plus sine theta. We haven't done this one yet, have we? I don't think so. 2 secant squared theta. So is it clear that the left side is more complicated? It's a sum. It's got fractions. Like, you probably need to work on the left side. Any idea how to start? Like, Jamie, what would you do here? Any guesses?
I'd probably multiply the bottoms by the reciprocals, and then you'd get a common denominator.
Okay, what I think you meant is the conjugate, 1 plus
Or-
sine theta.
Yeah, sorry.
Yes. This is a really important strategy. Whenever you see a 1 plus or 1 minus, you always multiply by the conjugate. You will get one like this. I mean, if it were me, I would definitely give you one of these, because it's not obvious. Unless you practice this, you would never know to do this. Okay, so go ahead and work this out from here, if you don't mind, and see if you get the right-hand side. Were either of you able to verify this one?
Almost.
Yeah, I got it.
Okay. So the hard part here is and you should consider this, is your instructor has to grade every student's like work. Like, they're actually looking at line by line, more so than usual here. So I don't know how complicated they'll make it, but what could happen is, if you're not neat enough, they sometimes try to actually follow your work here when they're grading this. So you really can't fake it if you don't know. That's why it's so good to try to practice these. Now, on the bottom, I would tend to make this cosine squared theta right away. That's an identity. Did either of you do that?
Yeah.
Okay, so then the numerator is 1 plus sine theta plus 1 minus sine theta all over cosine squared theta. The ones obviously add with the sine thetas cancels. You get 2 over cosine squared theta. And then this becomes 2 secant squared theta, which is the final answer that they're looking for. Niko, were you able to get to this point?
Yeah, I got to the one, like that one step above, and then
Okay.
I just finished it while you were explaining.
Great. Yeah, so these get harder also. So you're going to learn like double angle formulas, half angle formulas, some in different formulas, and it all kind of blends together. There's a ton of memorization. Just be careful that you don't wait till the end to learn some of those things. Is there anything else you guys would like to look at tonight?
I think I'm good. I think everything's covered.
Jamie,
No.
any trig on the soccer field you're using?
That was
Say
about
no.
it for me.
Nope. All right. Thanks, guys. I'll see you next time.
Thank you.
Bye now.
Bye.